Hi, I'm Antonio Pulito, and today I'm going to be talking to you about the Sustainability Learning and Exhibit Center that I created for advanced building modeling. The goal of this center is to inspire sustainability practices through holding different events and hosting different exhibits for visitors to come. The three key goals I had in mind while designing this building. The first is to maximize efficiency and self-sustainability of the building. The lead ways to do this are through using solar panels to generate electricity, as well as having a gray water reuse system within the plumbing. The second goal was to optimize the heating and cooling of the building. The building is broken into 6 distinct heating and cooling zones. By splitting it into these zones, I can group rooms that have similar sun and light levels throughout the day. This will allow me to be more efficient in how air is flowing to specific areas. And the third goal is to use recycled and innovative materials. For this, I wanted to focus on materials that weren't readily thought of as recyclable, but have shown promise for the future. Two main materials for this are concrete and steel. Concrete has been shown as a possible solution to carbon capture, where CO2 can actually be stored within it as it is poured. And steel has shown new developments as being more readily recyclable on a large scale. Within the building, there are 4 key systems of focus: the architectural, structural, HVAC, and plumbing systems. The building is located at Devils Lake State Park in Baraboo, Wisconsin. The building is to be positioned on the north shore of the lake, facing south. By facing the building south, I can maximize sunlight throughout the day and help reach the goals that I mentioned earlier. To start off this design process, I was able to import the topography of this space itself using SketchUp Pro and import it into Revit. From here, I created a conceptual mass model and laid out a preliminary room floor plan for this. While looking at this conceptual mass model, I use various software tools such as Climate Consultant, Revit Solar Analysis, and Insight Energy Analysis to understand the needs of the building and how I can help reach the goals of the building to be sustainable. Here is the final rendered version of the architectural model. As you can see, the roof incorporates a large solar panel array to generate electricity. And this south-facing side of the building has many curtain walls to maximize sunlight entering the building, helping with heating and cooling, as well as lighting. The curtain wall systems also incorporate shading mullions to help shade where necessary. Here are some more views. You can see a better view of those shading mullions themselves. And in the bottom right image here is the north side of the building. Looking at the room schedule, the building totals just around 36,000 square feet. There are many different rooms. There are restrooms on both floors, as well as an office space, cafe, exhibit halls, and more. Looking at the second floor, you can see the main lobby where guests will enter. From here, the 2 wings have large exhibit spaces, and the northeast side of the building has a specific office space where employees at the center can be isolated and work more freely. The southwest and southeast side of the building have elevators and staircases down to the first floor. The first floor includes more exhibit spaces as well as a cafe and lake overlook balcony. Moving off of the architectural into the structural system was created first by creating a grid sectioning. This grid sectioning allows me to more accurately place my structural system to not interfere with the architectural components. I decided to go with concrete columns and wide span steel truss beam systems. These span greater distances. up to around 60 feet and ultimately minimize the amount of columns that will be in those large exhibit spaces. Building also incorporates structural floors and walls to help support it. And here's just an overview of the entire structural system. You can see some of those concrete columns, the wide span steel truss beam systems, and other structural components. For HVAC, as mentioned earlier, there are 6 key zones to provide better air control. These zones are the west, central, and east zone for the first and second floor each. Looking at floor 2, we can get a better sense of how those zones operate. The west zone and half of the central zone run to a mechanical room on the west side, and then the east zone and the other half of the central zone run to another mechanical room on the east side. These zones allow different heating and cooling for these spaces, especially with different positioning of the sun throughout the day. These can be beneficial in promoting sustainability and allowing the visitors to feel more comfortable. The first floor plan has a similar layout with those systems going to the mechanical rooms on the west and east sides of the building. And here's just a closer look at the mechanical rooms and the AHUs within them. There are louvers in the architectural model to allow new intake air into the mechanical rooms, and each of the AHUs have a supply and intake vent system coming off of them. While designing the heating and cooling system, I did a load analysis on the entire building by creating an analytical model. This gave me data on the peak heating and peak cooling loads the building will experience, and actually designed the venting to meet the CFM for each room. The last system incorporated in this building is the plumbing. The plumbing is broken into 5 distinct restrooms, and within these spaces, there is gray water collection and supply systems, along with the typical domestic cold, hot, and sanitary lines. The restrooms have mechanical rooms for this piping. And here is a closer look at the actual restroom fixtures. This is the second floor men's and women's restrooms. You can see there's different plumbing fixtures like the lavatories, urinals, and then water closets. Getting a closer look, there are trunk and branch systems for the piping. It's important to coordinate how these pipe systems pass one another so there's not interference. Ultimately, while designing this, it was important to coordinate the different key building systems, the architectural, structural, HVAC, and plumbing. It's important that there's no interference between them and they can all operate as intended. Here is the structural and HVAC system. The structural system must support the roof, and the HVAC system should be optimized to be as high as possible, but should not interfere with the structure. And going into some of the interior spaces, here you can see the second floor lobby with the structural, HVAC, and architectural components. Exhibit Space 4 overlooking the lake has a similar layout, and you can see the same components. And here's just the first floor hallway. Those vents move throughout the hallways and interact with the other systems. Altogether, this project has taught me a lot about the different systems that must go into a building to have it operate as intended. Most important thing is to make sure the different systems are coordinating properly and can meet the needs of the people that will work and visit this space. Thank you.